Hello everyone, today we are going to troubleshoot best path selection scenario. This is the topology we have. We have site 1, site 2. In site 1, we have R1, R2, R3, R4 routers which is connected to the core switch and all are in a single broadcast domain which has a LAN subnet 192.168.3.0/24 where this LAN subnet is advertised to site 2, that is the R5 router, from R1, R2, R3 and R4. R1 advertises LAN subnet using EBGP, which has a connected WAN interface subnet 10.0.0.0/30, and R1 AS number is 1 and R5 AS number is 2. R2 advertises 192.168.3.0/24 LAN subnet using EIGRP, and its WAN interface subnet is 20.0.0/30. R3 advertise the LAN subnet using OSPF, and its WAN interface subnet is 30.0.0/30. R4 advertises LAN subnet using IBGP, and its WAN connected interface is 40.0.0/30, where R4 AS number is 2 and R5 AS number is also 2. In this topology, the question is, from R5, if you want to reach 192.168.3.5, which path it will take, whether it will take the path via R1 or R2 or R3 or R4. You can pause this video for a minute and come up with the answer. Post that, we will check which path it takes in order to reach the switch and why it takes that path. Hope you have come up with the answer. Let's log into the box and check which path it takes. So I'm logging to the site to R5 router, and I'm checking in the routing table for the switch IP, and it is learned via EIGRP via R2 router. So when this question asked in the open forum, most of them answered eBGP, that is via R1 then towards this switch. But that is wrong. So we will check why it choose EIGRP as the best route. So let's log in to the box and check whether we have received the routes from all the four protocols. So from EIGRP we have received the routes. However, we will also check the topology. So if you see in the topology also, this route has been installed as a successor route coming from R2 router. Now let's check the OSPF database also. So in OSPF we have only a single area, that is area 0. So the route, if we have received 192.168.3.0, it will be via intra area route. So if you see, we have also received the LAN subnet of site 1 192.168.3.0 and /24. Let's check the BGP table now. So in BGP table, if you see, we are receiving both in via internal, via external. That is both via IBGP as well as via EBGP. So if you see here, it chooses the path from IBGP as the best, whereas it didn't choose the path from external as the best. So if we look at this scenario, they will assume when a route received from EBGP as well as from IBGP, as EBGP as a lesser AD, they consider it prefers EBGP as a best route, or they also think EBGP is preferred over IBGP, but that is not the actual case. So in BGP best path selection, if you see the best path selection criterias, the first is the next stop is reachable or not. So here the next hop is reachable, then it checks the weight. So in this case, both has the weight 0. Next it checks the local preference. The local preference also is tie, both are 100. Next comes the locally originated route via network or redistribution or aggregate. So here if you see, the route which we are received from the IBGP, that is from the R4 router, it is local, whereas the route received from R1 router, it is via external. So it always prefers the locally originated route. So in BGP, it it choose this route as a best route when compared to the external route. So now in BGP we have a best path received via IBGP which has a AD200. Then the router compares the route which has received from EIGRP and OSPF. So then AD comes into the picture. So EIGRP has 90, OSPF has 110, and IBGP has 200. So as EIGRP has the lesser AD, it chooses EIGRP as the best route. So that's why it chooses EIGRP as the best route. We can also verify this by using debugs. So let's perform a few debugs and check how the route is getting installed in the routing table. So we will perform two debugs. One is for BGP update and another is for routing. So before that, I have created an ACL to match only that particular subnet. So here in the ACL, if you see 192.163.0, which has a /24 subnet, I have configured in the ACL. So we will configure a debug for the BGP update. So the debug for BGP update, which contains this particular prefix, and next we will configure for a debug for a routing update, again which using the same ACL which has this particular prefix. Now what we will do is we will shut down the LAN interface of all the WAN routers in site 1. So I'm shutting down the LAN interface. So I have shut down the LAN interface in all the 4 WAN routers. So if you see, the route has been withdrawn, so we can check in the routing table also. See, there is no route in the routing table for the LAN subnet of site 1. Okay, now what we will do is we will enable the LAN interface in all the WAN routers and see how the routing table is getting updated. Router 1, and oh shit. Okay, so we got the debug output. Let's go through the debug output. So if we start with BGP, then it is a BGP update, and if it has a RT, then it is a routing table update. So first we have received an update from the R4 routers, that is IBGP, for 192.163.0/24 prefix. So then it has installed in the BGP table. Then it is also installed in the routing table with the AD200. Then it has received the route from OSPF, which has AD110, and it is installed the OSPF route. As when compared to IBGP AD200 and OSPF 110, OSPF is much more preferred. Then it installs the OSPF. Then it also received an update from the R1 router, which is EBGP, but there is no change in the routing table or in the BGP table, because IBGP is preferred here. Then it again flushes the routing table because it received a route from the uh, EIGRP, that is from the R2 router 20.0.0.1, and as the AD of when compared to OSPF and when compared to EIGRP, the AD of EIGRP is much more less than OSPF. So it installs the EIGRP route as the best route. Hope you are all clear with the concepts. Thank you for watching the video. For more videos, please subscribe to the channel. Thank you.